apologize for that. So what is it? The observed numbers of cancers, and so you can see looking by well characteristics, so children who live in counties where there are gas wells, horizontal gas wells, and Marcellus shale wells. Compare, now let me tell you what the SIR is. That's the standardized incidence ratio. So that's our measure of relative risk. What the SIR actually tells you is that we compare the number of cases of cancer to the number we would expect in that population if the population had the same rates that we see in the rest of the United States and the general population. So the idea is, if they have the same rates as the rest of the country where there's no fracking, we would expect to see some number. And then the SIR is the number observed divided by that number expected. So when the observed and the expected are equal, the SIR is 1.0. What that says is, number of cases of cancer you saw is exactly what you'd expect based on the general population of the United States rates. Okay, so 1.0 means there's nothing going on. If the SIR is a little less than 1, it says we saw a little bit less than we expected. If it's above 1, we saw a little more than we expected. And then we calculate a 95% confidence interval around the SIR. Confidence intervals are actually familiar to everyone in the room. When you come up to an election, the pollsters always tell you Mr. Obama, President Obama is expected to get 52% of the vote, plus or minus 3% margin of error. That's confidence interval. In other words, the statisticians calculate, well, we've polled 1,000 people, 52%, they're going to vote this way. The margin of error around that estimate is about 3%. Okay, so that's what the confidence interval is. And if the SIR is above 1 and the confidence interval is also above 1, meaning both the lower number and the upper number, it says that's a significant excess. If the SIR is above 1 but the confidence interval includes 1, it says that's not a significant difference. In other words, the margin of error includes 1.0. The margin of error includes that there's really nothing going on. All right. And so I've highlighted the 2 statistically significant findings in this whole table. The first is in blue. In counties where there was fracking or where there were gas wells, before the drilling began, there was a significant deficit of all cancer. So the SIR was 0.95, and the confidence interval went from 0.91 to 0.99, so it didn't include 1. And then the other one is the red one. After drilling, CNS, central nervous system, brain tumors, were slightly in excess after drilling in counties where there were gas wells. Okay, 1.13, and you can see the confidence interval goes from 1.02 to 1.25. Okay, all the rest of the results, no significant findings. So nothing for horizontal wells in leukemia or horizontal wells in brain tumors, horizontal gas wells, leukemia, nothing, brain tumors, nothing. Marcellus shale wells, leukemia, nothing, brain tumors, nothing. Okay? All right, so a couple of things we want to look at a little more carefully. And so the important thing is before drilling to after drilling, what's the pattern? Are the rates or are the SIRs going up? Are they going down? Are they staying roughly the same? And are you getting any significant results? Okay. Where's the other table? Uh-oh, I didn't put the other table in. There's another table. Forgive me for that. Thanks. There's another table that I thought I had it here that actually categorizes the counties by the intensity of drilling. So remember back on the no wells, less than 500, 500 to 1,000, 1,000 to 2,000, more than 2,000. looking for the trend in SIRs as drilling intensity goes up, both before and after. When we looked at that for the CNS tumors, what we found was that what was driving that significant association was a positive association in the counties that had the lowest amount of drilling. So not the counties with no drilling, but the counties that had 0 to 500. And the risk was not increasing with the number of wells. And so even though there's that one significant finding, when we looked by intensity of drilling, in fact, the risks were decreasing, and there was no finding that would suggest it had anything to do with drilling. Okay. All right. So this is the first study that's been published that I've been able to find that examined childhood cancer in relation to hydraulic fracturing activities. There is no pattern of increased incidence of leukemia, brain cancer, or all cancer combined in children after hydraulic fracturing. I want to, as good scientists are, I want to be cautious about over-interpreting the results. It doesn't answer all questions, but at least it takes a state where there has been an awful lot of fracturing and an awful lot of gas drilling. It looks carefully at the cancer rates in children, and it doesn't find any patterns that would suggest that there is anything going on that we should worry about. Okay. I think this is an awfully important point. Health effects from chemicals, when we're talking about hydraulic fracturing and cancer risks, what needs to be stated is the only way there could be a relationship is if there's some exposure to chemicals. Okay, and there would have to be chemicals that cause cancer. Health effects cannot occur in the absence of exposures. Health effects can only occur after adequate exposures. So what I want to shift the emphasis back to is that the important issue, if you're going to worry about cancer risks, is to think about, well, is there really exposure? In other words, is there really a pathway by which the chemicals that are being used could possibly be getting into my body or my family's body or my children's body? In the absence of some plausible exposure pathway, you cannot have an adverse health effect. And so that's the point to keep thinking about every time you hear on the news, oh, some health effect is linked to fracking. You've got to say, well, did they talk about exposure? Did they talk about how that chemical actually got into people? Or was this a study where, well, okay, there was some trend in the population data, but we don't actually have any evidence that chemicals were involved? Okay, I'm going to stop there. I'd like to take questions.